last class, we were in chapter 2 and we were kind of moving right along. And we were talking about these primitive data types. Okay, and I said there's 4 of them. Right? They were the ints, the doubles, the char, and the boolean. So I'm going to jump back to those for just a moment. And I'm going to go in the book because I have a note about page 45. And here is the table. And I'm going to split this table that way that talks about ints. Okay, and we said ints, yes, great. But there's almost more like an int family, which if I want to represent an int, depending on the range of numbers I want to use or the amount of memory I want to use, I could pick a different name for a data type. For example, int is right here. It's 4 bytes. So when I declare an int, it's going to give me a location of 4 bytes, which would allow me to have this range of numbers. Hoi polloi.
It looks like 3 people have just joined.
Say that again.
It looks like 3 people have just joined. David,
okay.
Dell, and Moose.
I will double check that in a few moments. Thank you. So I have the int, which was 4 bytes. Well, let's go up to this one. If I only needed a couple of numbers, I might want to declare something byte. Chances are 99% of my students will use int, just because that's the one you remember and you can use it all the time. But don't ever be surprised if you see byte or short or long, because you can get this range of numbers. Now, why are they putting this in here? And why? Well, I want this to make sense for you. Okay. So if I look at 1 byte and I added all those numbers up, how many numbers are there? $256, right?
Mm-hmm.
I get 256. 256 is the same as 2 to the what power?
8th.
8th power. And remember when I said a bit is a 0 or a 1, and if I had 8 of them beside each other, I could get this range of numbers. So by using light bulbs, I could represent what I need to represent there. Okay. What do you think this guy is? 32,000, blah, 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 up to 32,767. Believe it or not, that's going to end up being 2 to the what power?
20th?
No. Remember we said a byte is 8. So 2 bytes would be.
Is it 2 to the 16th?
It's 2
So they multiply. Okay.
Yeah, it's 2
or
to
the exponents multiply.
Right. So if you looked at 2 to the 16th power, it's going to be 65,400, blah, 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 blah. Okay. So these are all done for a reason. It's the amount of memory they use. And again, we start talking bits and bytes. Down here is my real family. We use double all the time. We're just used to it. But there are times you'll hear float for the term floating point number and the range of numbers it would give. Okay. This has 7 digits of accuracy. This has 15. Most of the time we'll use double, but I wanted you to be aware that this float does exist as well. So don't be shocked if you
Okay. So how about we explain why we would use these alternative things?
Say again, Anthony.
Why we would use these alternative things?
Memory. Back in the day, memory was an issue, so we didn't waste memory. Because I can remember the first computers I was teaching with had 4 kilobytes of RAM and no hard drive. So we had to be real careful with the amount of memory we used. So it was a little bit more of an issue back then. In fact, back then, the int data type, like when I taught Pascal, was only 2 bytes, because this was a range of numbers that my students knew back then, because we actually would do a program where it would get higher than this. So if I added 1 onto 32,767, what would I get?
Would you get some type of error?
No, actually what it does is it wraps around into this negative area and starts going from there. So 32,767 plus 1 gives me 32,768. Okay, that's a little old school lesson, but I wanted you to be familiar with, we have the 4 primitive data types, and the int and the double sort of fall into families. All right, so some of your math background is now going to start to come into play. And as we move along into section 2.5, you start to see, we're going to get into arithmetic operators. Remember the other day I said, we're going to start being able to program and do something like cost equals 40 plus 30 times X. Excuse me, we didn't even go with X. We went with hour. Well, in order to get that in our programs, we need to make sure we know what all the arithmetic operators are. Okay, so here's a couple of them listed: addition, subtraction, multiplication. You're good with those 3. The next one that comes up is division. Now, division, there's going to be 2 types of division we need to talk about, and we'll do that in a second. Finally, the last one is the percent sign. It's an arithmetic operator, and the operation that it does is called modulus. It gives me the remainder. It gives me the remainder. So in our world, we look at these problems and we just start ripping away and getting an answer. I'm going to start with this first one, 12/4. Well, in the computer world, I see that number 4.0 and I see this number 4. What data type would you say 12 and 4 would be, thinking about our data types now in the computer world? 12 is what?
Integer.
Integer, and the 4 is an integer. So when the computer sees an integer divided by an integer, my answer is going to be an integer. What's 12 divided by 4?
3.
3.
3. Good. What is 15 divided by 4? How many?
Not an integer.
Well, how many 4? Yeah, well, no, because this is telling me I'm going to make it an integer. How many?
So it'd be, so
Be
it's
3.
3.7.
Nope, it's
just
just
3.
It's just 3.
Okay.
Okay,
Got it.
that's how the computer world works. It's just 3. Okay,
But I'm confused. How does it make it 3? It was
because this is
3.75.
okay, because this is an integer and this is an integer. The computer recognizes I'm dividing 2 integers. I'm going to make it a 3. Now, if I jumped over here and one of these is a real and the other's an integer, now what's that answer going to be?
3.75.
Yeah, now it gives me a real answer. Okay, so when I mix data types, it goes with the data type that uses the most memory. In the chart we looked at a few moments ago said reals use the most memory. So we have integer division, we have real division. So if I kept going, this is 3, this is 3. How many times does 4 go into 3?
0.
0. Okay, now you know why we're taking time to cover this. 12 divided by 4.0, what is it?
3.0.
Excellent. 3.0. My result is a real. It's not just 3. What is 3.0 divided by 4?
0.0.
No, it's actually going to give me the real.
Oh,
Zero.
1.
0.75.
Yeah.
Oh, yeah.
Yeah. Yeah. It's one of those where once you see it, it's like, oh, okay. Sounds good. Oh boy. Modulus. How many times does 4 go into 12?
3.
What's the remainder?
0.
Good. How many times does 4 go into 15? You know that. What's the remainder?
0.75.
75.
No.
2.
3.
3. 3. How many times does 4 go
Oh,
into 3? How many times does 4 go into 3? None. What's the remainder? 3.
0. 3.
3. Mhm.
Okay.
I mean, again, start thinking of that first one. 12 divided by 4. It goes in 3 times and the remainder is 0. Okay. 15 divided by 4. It goes in 3 times. Its remainder is 3. If I said 3 divided by 4, it goes in 0 times. Its remainder is 3. Okay. Silence is consensus.
Yeah.
Okay,
Yeah.
good.
Can I actually ask a question about the real division part for a second?
Yep, yep, yep.
So, in your programming,
Uh-huh.
if you just have like, if you declare like the number 12 and 4 as a double,
Okay.
and then you divide them, would it give you the answer of 3 or 3.0?
It'll give me 3.0. It'll go
okay.
with the reals. Yes.
Okay.
Yep. Do-do-do-do-do. Boy, this is one of the advantages of remote. I don't have to take the time to write this stuff on the board. I can just fire it out. All right, my experts, there's 4 problems. Let's see what you can get for an answer. Gallery view. I see David is here. Good. Mustafa is here. Good. And Dill is here. Good. I don't want to mark you folks absent because I know we started before you folks got here. Four problems. I'm going to pick random names to give me answers. Let's go with Gilda. Gilda, do you have an answer for the first one?
Yeah. Yes, I think so.
What do you have?
I have 5 for the first one.
Excellent. 5. The integer 5. Because I get 2 integer division. I'm going to get an integer for an answer. Kevin, do you have an answer for the next one?
Oh, you mean me?
Yeah, Kevin,
Oh no, it's Kevon.
Kevon.
Yeah, yeah. But
I think I said
no,
it. Oh, I said Kevon. That's right. I'm sorry. Kevon,
no, you're good. But no, I don't have an answer
not
for
yet?
that.
Okay. Let's grab another name. David Ulishny, do you have an answer?
Would it be 56?
I hear 56. Can I get a hell yeah from a redneck girl? I do have a hell yeah. I do get 56. Let's see, this is 8 plus 12 times 4, 8 plus 48. I'll go with 56. I'm good with that.
That's what I got.
All right, Jacob, you look confident. You have the next one?
This is the only one I'm not confident in.
Ah!
Is the answer 0?
I'm asking you what's the answer. Now you're asking me what's the answer.
I have 0 as the answer.
I hear 0. 21 gets done first because of the parentheses.
Hmm.
And I'm gonna mod, which gives me a remainder of 1, and I look like a 0.
All right.
Good. Good. This class must be smarter than I thought. Good job, Forrest. We don't have a Forrest, do we? Samantha, do you have an answer for the next one?
I got 9.
I hear 9. All right. You didn't ask me. You just said 9. Like Jacob. Yeah, is it 9? 3 times 9 slash 3. 3 times 9 goes next. 27 divided by 3. I'll take that. Sounds good. We get to the 9. put the lotion on the skin, right? No, don't do that. Okay. Math Pal. Now, still working with all of this math stuff to allow me to do computations in programs. Okay. We've now expanded our ability, and we want to be able to do powers. Now, one of the problems is it's not the caret, which would have been kind of neat, but because of ints and doubles and decimals and all that, powers just aren't going to work with the caret. So there's actually something, and we're not going to get into this so much yet, but I'm going to plant the seed. This is called a class. So class is a bunch of stuff in Java that's saved under this name math. Okay. Inside of that class, we have an operation. It's actually called a method. That's a block of code that's stored in the class that says, hey, you send in 2 numbers and I'll calculate what 4 to the second power is. Okay. Now, whenever I do this, my result is going to be a double. So when I come back, result is now going to have the value of, this is going to return 16.0. So result would now be 16.0. Another method that is written for us, stored in this class called math, is SQRT. SQRT will take the square root of a number. Okay. Once again, the result's going to be double. So when this is done, answer is going to get the value of 3.0. 3.0. Now, just like you, come on, mouse. If I share my screen and it's going really slow, and I jump over to something that looks like, go up. Here we go. I'm now going to Google something. I'm going to Google Java math class. Okay. Again, I said this is called the class math. We're in Java, and I have this method pal. I have a second method in the math class called SQRT. And I'm wondering if I could go to the math class, and here's the best website I found, docs.oracle.com. And we're going to take a look at the math class and see if there are other methods like PAL or SQRT. And when I come in, all of a sudden, oh, there's an interesting field. Here's something, PI. We're going to keep that in mind for later. We know pi. Well, what's already built in the math class is pi. And it's going to be 3.141592653589793, daddy. But let's see, I'm coming down through this column right here. This is methods and their description. And it looks like I have absolute value. I'm going to go check out PAL. That's P. There it is. PAL. It brings in a number. Whatever it brings in, it converts it to a double. And the other one's a double. And it raises the first argument to the power of the second argument. Over here on the left side is the return type. So when I had ants on the other page, ants has to be declared as a double, so I can return it to a double. Okay, what else did we say? We said square root. Oh, there's sine. Here's square root. It's going to bring in a double. It's going to find the square root and return it. So somebody wrote the blocks of code to do all of these things. The 2 most popular are the ones that I just showed you, but there's a lot of them in here. A lot of them in here. Okay, floor is an interesting one. But once again, Oracle, this docs.oracle is a big help. Just Googling math class, Java, got me here. Okay, so now That's enough of me talking. I need to prep you, and we're going to go and we're going to take a look at creating a program. Okay. Quadratic formula. We all know what the quadratic formula is, right? Because you're supposed to have had college algebra to get in here. Ironically, to get into the first course at Penn State, Harrisburg, you need to have calc. So I think we're good with where we are. So, but the quadratic formula, who didn't I call on today? Somebody just went, oh crap, I don't know what, who knows what it is? Quadratic formula is?
Negative b plus or minus
Yep.
square root of 2ac, or no, b squared minus 2ac all over
B
2a.
squared minus 4ac all over 2a.
See, I wrote this into I wrote the program into my graphing calculator and forgot most
Okay,
of it
all
last
right,
semester. It's
all
in there
right.
somewhere.
And in
floating
fact,
around.
this guy inside of here, b squared minus 4ac, does it have a name?
The discriminant.
Yeah, discriminant. The discrim is b squared minus 4ac. Okay. So if I wanted to write a program to do this, first of all, I need to make sure I understand what's going on with a, b, and c. And that goes back to the whole y equals ax squared plus bx plus c. And this is actually the situation where I want to find roots. So I'm going to say this becomes 0. I want to know when that statement is true. Okay, so this guy up here should give me, for an answer, 2 roots. All right, so
Question,
yeah.
isn't the quadratic equation x equals, not y equals?
Oh, you're right. And I did it in blue marker. Shh, don't look. Don't look. Yuck, 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 yuck. Who was that picking on me, saying that that's X?
It was your guest.
Oh, okay. All right. Thank you. Thank you. Okay. So I'm over here, and before I even try to write a program, I need to make sure I know what's going on. And this guy is the roots. So I go back to, oh, yeah, no, wait a minute. This is something like, if I factored this guy into something like x minus 3, x minus 1, for example, 0 equals x squared minus 4x plus 3. Okay, so if I ran this program, I'm going to make all this clear now. If I wrote this program and asked the user, what is A? They typed in 1. What is B? They type in -4. What is C? They type in 3. The roots would be +3, +1. Okay, well, let's see if we can get started on a program. So I'm going to go back and share my screen, and I'm going to go to, I don't see it.
Well,
There it is.
I believe this would require 2 problems as it has a plus or minus.
That is correct. Okay, so everybody can see my screen, and I like to have something like this saved, maybe saved as temp, so I can load it up and I'm already partially into my program, if that makes sense. Some of you will type it over and over and over and over, but so I have all this done. First thing I'm going to do is I'm going to save this, and I'm going to call it quadratic, and I'm going to do a file, save as. I'm going to put you in groups, so I want you to pay attention for right now. So I'm going to do a file, save as, so I make sure that my computer's running slow. So I can do file, save as, and it says quadratic. I just want it to be quadratic, and it's going to put the Java extension on, and it's saved. Okay. So I don't want you typing this up because you're going to get ahead of things. But right now, I'm going to do my declaration. I need some variables and some data types. All right, I can think of 6 that I'm going to create. All right, first one is A. What data type would A be?
Probably, I would say an integer.
Yeah, let's just make it an int. In
Just
fact,
for
I'm going to use
simplicity.
A, B, and C. Okay, I know exactly what A, B, and C mean. They're not very descriptive, but in this situation, I know what they're going to be. Okay, I'm going to have these. Oh, well, that's funny. Double. Come on, double. Again, it turned purple, so I know it's right. As Anthony mentioned, we're going to have two answers. I'm going to call it root 1 and root 2. In fact, I'm going to have a third one, and I'm going to call it discrim, short for the discriminant, because I'm going to use that instead of making root 1 this giant thing, and root 2 this giant thing. Okay, now we don't know how to input anything yet, but my test data was A equaled 1, B equaled -4, C equaled 3. Now, what do I need to do? I need to be able to come up with the discriminant using what I had from my sheet, and I need to come up with what is root 1 and what is root 2, and then I need to display everything. I have a couple of system.out.printlns to display everything.
What is the discriminant?
Because otherwise root 1 is going to be -1 times B plus math.square root parentheses B times B minus 4 times A times C parentheses around all of that slash parentheses 2 times A parentheses. That gets long. So we're going to break it up a little bit. Now, we as in not me, we as in you all. So I'm going to put you in groups. When you get this done, call me in, take a look at what you have, and then we're done for the day. And I will say, have a good weekend at that point. Okay.
So you write.
You're going to be doing what I started and then putting the actual formulas in and displaying the output.
Okay. Please say your code again.
I open breakout rooms.
Hey, Professor.
Yeah.
Okay, how do we remember what the code was though?
That's what you're going to learn in your groups. Who else called me?
I mean, how do we remember? That's what I meant, like what you put in.
You can make up your own test data if you want.
Okay.
Professor, I'm doing Zoom on my phone right now because I'm not able to be in my house right now, so I'm not I can't like use JGrasp from my phone, so I'm not able to type this up.
Are you able to join the group and just watch?
Yeah, I can do that. I just wanted to let you know.
Try that. Yeah, I just want one person in each group to type.
Okay.
All right, so I need one person in here to share your screen.
Oh, okay.
They'll be the typer and everybody else tell them what to type.
Okay, I can do that. You guys mind if I do that?
That's fine. You can, yeah.
Okay, sure. Okay.
All right, so Jonathan, can you share your screen?
Yeah, I can.
Why don't you share it and do the typing and let everybody else do the talking?
Oh, I'm sharing and typing. Okay. Let me sec. How do I share my screen? There it is.
Good.
Is this working?
Yep.
Okay. I was recopying the program.
All right, so what we need is one person to share their screen. And then everybody else, they'll be the typer. Everybody else will be the telling them what to type. Ian or Aiden, do you want to share your screen?
I actually have JGrasp on a different one.
Okay. Oh, there we go. Anthony's sharing his. So Anthony, you're going to open up JGrasp and everybody will tell you what to type.
Here he is.
Yep.
Oh, okay, cool.
We need somebody, Darren, somebody, Gabe, share your screen and have JGrasp up. And then you'll be the secretary of the group and everybody else will tell you what to type.
Cool. I think someone in the group already has JGrasp started up, but if not, I can open
They
it.
can share, somebody share and then go from there.
Okay. I can.
One of us will share JGrasp and the the others will tell him what to, or her what to type.
Correct. So somebody click share screen and have JGrasp ready and then go from there.
Okay.
You got it, Darren?
Okay, I can. Yeah, I wasn't
Okay.
sure what was going on. All right, I'm opening it now.
And then just share. Uh-oh, I'm still recording. I want to stop recording.